So here is another question on electric potential. So here it is given that 3-point charges, okay, 3-point charges are given having values of plus q, plus 2q and minus 3q. Okay, this is minus 3q. Okay, are placed at the vertices of an equilateral triangle ABC of side small l. If these charges are displaced to the midpoints A1, B1 and C1 respectively, that is q to A1, plus 2q to B1 and minus 3q to C1, find the amount of work done in shifting these charges to the new locations. So here this question is based on the concept of electric potential energy. This. So basically what we have to do for the initial location of the 3 charges at points A, B and C, okay, A, B and C, we have to find the initial potential energy, okay, the initial potential energy, and then when the charges are moved from here to here A1, plus 2q to here from B to B1 and from C to C1, when they are moved, okay, here plus q, then here plus 2q and here minus 3q, then again we have to determine the final potential energy, and the work done in movement or moving these charges is final potential energy minus initial potential energy, the change in potential energy. Okay, so for the initial potential energy Ui, okay, initial potential energy, we have already discussed about electrostatic potential energy or electric potential energy, the formula, the theoretical concepts. So basically the electric potential energy of a multi-charge system, basically here for this 3-charge system ABC, plus q, plus 2q and minus 3q located at points A, B and C, the initial potential energy is given by 1 by 4 pi epsilon 0 qa qb by AB plus QB QC by BC, where BC is the denominator is the gap or the separation, the shortest distance between these two charges, plus QC QA by AC. This is the thing. So here it will be 1 by 4 pi epsilon 0, since it is an equilateral triangle, so AB is equal to BC is equal to CA or AC, that is equal to small l. 1 by 4 pi epsilon 0 QA QB, that is plus Q into 2Q by L. Then here QB is plus 2Q, QC is minus, so it becomes minus 2Q into 3Q by L. Then again QC, so it is minus QC QA, so it will be minus 3Q into Q by L. This. So this will become one by 4 pi epsilon 0 2 q square by L minus 6 q square by L minus 3 q square by L. So that is equal to 1 by 4 pi epsilon 0. How much is minus 9q square by L? Minus 7q square by L is equal to minus 1 by 4 pi epsilon 0 7q square by L. That is the initial potential energy of the system. Okay, then for the final potential energy, now here if you see, the charges are moved to the midpoints A1, B1, C1, A1 between A and B, B1 between B and C, and C1 between C and A. So again here it forms an equilateral triangle. So here A1 C1, that is L by 2. Here A1 B1, again that is L by 2, and B1 C1, that is also L by 2, because A1 B1 C1 also forms an equilateral triangle. Okay, so here the electrostatic potential energy for this shifted charges, that is equal to, which is the final potential energy, 1 by 4 pi epsilon 0 q A1 q B1 by A1 B1 plus q B1 q C1 by B1 C1 plus q C1 q A1 by C1 A1. Okay, so that is equal to 1 by 4 pi epsilon 0 q into 2q by L by 2. Then it will become minus because this 3 minus 3q is involved, so it is 2q into 3q by L by 2 minus 3q into q by L by 2. Okay, this. So again that becomes 1 by 4 pi epsilon 0 2q square by L by 2 minus 6q square by L by 2 minus 3q square by L by 2. So that is equal to again 1 by 4 pi epsilon 0 minus 7q square by L by 2, that is equal to minus 1 by 4 pi epsilon 0 14q square by L. Okay, this is the final potential energy. This is the final potential. This is the initial potential energy. This is the final potential energy. So now work done in shifting these charges is difference of final potential energy and initial potential energy, which is equal to minus 1 by 4 pi epsilon 0 14q square by L minus 1 by 4 pi epsilon 0 7q square by L. So that becomes minus 1 by 4 pi epsilon 0, this becomes plus minus minus plus pi epsilon 0 7q square by L. Okay, this is the work done in shifting the charges. minus 1 by 4 pi epsilon 0 7 q square by L. So here we are only using epsilon 0 because nothing has been mentioned whether the charges are present in any other medium. So we are considering free space or air. So absolute permittivity only, no relative permittivity. Relative permittivity of free space or air is equal to 1. Okay, this. So here this is the thing. So here is another question. It is given that to calculate the voltage needed or electric potential needed to balance an oil drop carrying 10 electrons when located between the plates of a parallel plate capacitor, which is separated 5 mm apart. The mass of the oil drop is given 3 into 10 to the power minus 16 kg, and the charge on the electron, as we know, 1.6 into 10 to the power minus 19 coulomb, and the acceleration due to gravity 9.8 meter per second square. Okay, so this is 6 into 10 to the power minus 19 coulomb. Okay, so let us try to understand. So we have two plates of a parallel plate capacitor. Which are separated 5 mm, the separation gap, the separation distance. So let's say this is the positively charged plate and this is the negatively charged plate. So the electric field will be acting in this direction. So here we have an oil drop. Okay, it consists of 10 electrons. Okay, it has 10 electrons. Okay, and the mass of the oil drop, that is equal to 3 into 10 to the power minus 16 kg. The charge in the oil drop will be equal to the charge equivalent to 10 electrons, that is 10 into 1.6 into 10 to the power minus 19 coulomb. So because of the charge in this oil drop, okay, in this oil drop, because of the charge, negative charge, okay, minus 10 point, because it will be negative because it is electron. So because of this negative charge, there will be an upward repulsive force because of the negative charge at the bottom. Okay, this QE of magnitude QE, and because of its mass, there will be a downward gravity force, force of gravity, mg. So this will be the force of gravity, and this will be the electric force, which is repulsive in nature. Okay, because of the negative charge plate in the bottom and the attractive in nature because of the positively charged upward plate, because positive charge attracts negative charge and negative repels negative charge. So in order for the oil drop to be in balance, stationary, the upward electric force must be equal to the downward gravity force. Okay, Fe is equal to mg. Now Fe is equal to charge in the oil multiplied with the electric field. Okay, this, and gravity force Fg is equal to mass of the oil drop multiplied with acceleration due to gravity. Okay, that implies here, in order to calculate the electric potential, we have to first determine E. Okay, we have to determine E. So Q oil E is equal to mass of the oil into G. That implies E is equal to mass of the oil drop into G by charge on the oil drop. That is equal to 3 into 10 to the power minus 16 into 9.8 by 1.6, that is 10 into 1.6, so you can write it 1.6 into 10 to the power minus 18 coulomb. Okay, same, 10 into 1.6 10 to the power minus 19, that is equal to 1.6 10 to the power minus 18. So this is coming around 1837.5 Newton per coulomb or volt per meter. In any unit you can express. So here it will be appropriate to express it in volts per meter. So the electric field in between these two plates, that is equal to 1837.5 volts per meter. Separation gap is 5 millimeter, which is equal to 5 into 10 to the power minus 3 meter. Now we know electric field is equal to electric potential between 2 points divided by the separation gap. Okay, this. So here it will be equal to that implies the electric potential is equal to electric field multiplied with the separation distance, that is equal to 1837.5 into 5 into 10 to the power minus 3 meters. So this much volt per meter, this much meter. So the result is 9.1, rounding it off, 9.19 volt or 9.2 volt. So 9.19 volt. That is right. This is the electric potential between the two plates. So where this come from? The separation gap from potential gradient. That is equal to minus dV by dr, the separation gap. Okay. So the magnitude is only dV by dr. So for the total thing, that is the rate of change, the total thing is this much. V by d or V by r. Anything, whatever we write, it is the right thing. So r is the rate of change of electric potential with respect to distance. This is for the total thing. Okay, for the total initial to final point in between 2 points. Okay, V by d, electric potential divided by the separation gap. In between 2 points, if electric field is something E, the separation gap is d or r, whatever you want to write, this much, then this is the relationship between electric field, electric potential and the separation distance. Okay, so this is the result, 9.19 volts. So this much electric potential in between the two plates of the parallel plate capacitor is required to balance the oil drop, which has this much values: mass, charge and acceleration due to gravity. Okay.